The morning of April 17, 1945, in the dense jungle scrub ahead of the Allied landings on Okinawa, Japan, a single-tank crew of the Imperial Japanese Army's Tank Regiment stared in disbelief at the battered rear hatch of a captured American medium tank, the M4 Sherman. What they discovered in that hulled vehicle: an intact 75mm gun, still poised for action, ammunition racks undisturbed, and no blast-burn wreck inside, shook the assumptions of Japanese armored doctrine to its core. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. For months, the Japanese armored crews had been taught a clear, straightforward set of beliefs. Allied tanks were slower, more cumbersome, more vulnerable. Their doctrine emphasized mobility, surprise, and clearance of terrain. When faced with enemy armor, they assumed the firepower. Challenge could often be avoided rather than directly met. We carried a 70mm class gun, in its original low-velocity version, and armor that might resist small arms and light autocannon fire, but certainly could not match the thick frontal armor or high-velocity guns of Allied designs. And yet here it was, a Sherman medium tank, knocked out but not immolated, its interior surprisingly intact, its 75mm gun still aligned forward, the ammunition stowage untouched. The irony was stark, but the implications were more profound. Why had their doctrine not anticipated such a machine? Why had their intelligence estimates dismissed the Sherman's resilience? And most urgently, what did this mean for the Japanese armoured units now preparing for a fight that would be pinned around the home islands? By early 1945, the Pacific War had entered its final and most brutal phase. The United States, after securing island after island in the Marianas, the Philippines, and Iwo Jima, was poised for the long-planned invasion of Japan's home islands. In response, Japanese planners shifted to a defensive posture. The emphasis on naval power and air supremacy now gave way to anticipation of amphibious landings, attritional defense, kamikaze attacks, and expanded use of tanks in a homeland defense role. For the Japanese armored forces, the motto remained mobility, surprise, and combined arms flexibility rather than heavy frontal confrontation. The Chi-Ha series, despite its obsolescence compared to Allied armor, had functioned in Asia and the Pacific with moderate success where terrain, logistics, and air superiority still favored Japan. The industrial base, however, had long lagged behind the United States and its allies. Steel, fuel, experienced crews, spare parts, and production capacity were all in severe decline. At the same time, from the American side, the Sherman medium tank had emerged as the workhorse of countless armored, infantry support, and amphibious operations. Its 75mm gun, in many versions, reliable drivetrain, ease of repair, abundant parts, and mass production meant it was everywhere. Because of large numbers, logistical robustness, and standardization, it often prevailed not necessarily by being the heaviest or most powerful tank on the battlefield, but by being there when needed, repaired when shot, and supported when isolated. Numerous post-war studies and wartime intelligence would stress that the Sherman era was less about raw armor versus gun numbers and more about sustained utility, flexibility, and recoverability. In short, the Japanese mindset expected the war to be decided in terrain favorable to infantry and air power. Their tanks were supporting forces, not spearheading confrontations with large Allied armored formations. Their tank doctrine did not emphasize slugouts with comparable medium enemy tanks that could absorb hits, be repaired, and return to battle. Meanwhile, the Allies, and especially the U.S. armor forces, believed that sustaining the fight, keeping the machine running, and exploiting industry and logistics mattered more than any single dwell. When, then, a Japanese crew found a disabled yet unburnt Sherman among the wreckage of Okinawa, the confrontation was not just of steel and treads, it was of belief systems. What they observed undermined the prevailing Japanese expectation that a penetrated tank must burn, that vulnerable logistics or shallow stowage will doom the vehicle, that numeric superiority or high-powered guns would automatically yield armored dominance. Over the next minutes, we will trace how the Japanese crew's initial confidence gave way to confusion, how forensic inspection of that machine unearthed a structural surprise, and how the consequences rippled through the remaining armored 12 units of the Imperial Japanese Army, arriving in the final months of the war when no redesign could appear fast enough. The Japanese crew of the Tank Regiment approached the disabled Sherman cautiously. The humid Okinawan air thick with smoke, gunpowder residue, and the acrid stench of burned vegetation. From a distance, the tank had appeared dead and harmless. Their first inspection focused on the 75mm gun. Unlike their own Chi-Ha, whose low-velocity 70mm could barely pierce early war. Allied tanks at even close range, the Sherman's gun barrel, though unassuming in appearance, carried a high-velocity round capable of penetrating the Chi-Ha's armor from over 2,000 yards. Japanese crews had trained for tank confrontations at a maximum of 500 to 1,000 yards. The concept that an enemy tank could reliably strike beyond double that distance challenged all prior tactical calculations. Lieutenant Hiroshi Kato, commanding the detachment sent to survey captured Allied armor, ran his hands over the Sherman's glacis plate. The armor was sloped, moderate in thickness, yet incredibly resilient. Even where the tank had sustained hits from the Type 90-7 gun and smaller calibre anti-tank weapons, there was no catastrophic breach. Unlike previous encounters with Shermans, in which burning fuel or exploding ammunition destroyed vehicles, this specimen showed no signs of the inferno that usually followed a penetrating round. The crew moved to examine the interior. The ammunition stowage was intact, neatly lined along racks designed for rapid loading and shielded by armored partitions. The Japanese had expected the internal propellant to ignite from a penetrative hit, as had happened in countless Shermans in other theaters, and as was standard in their own doctrine, a penetrated tank meant a fiery death. Here, instead, the shells remained cold and intact. Kato's notes, later included in regimental intelligence reports, stressed the psychological shock. We had trained under the assumption that enemy armor, when struck, would burn. We expected to approach disabled tanks with caution, knowing that survivors were rare. Yet here was a vehicle that had taken multiple hits and yet remained structurally sound and non-combustive. Our doctrine did not prepare us for this anomaly. Their forensic examination continued. The transmission and drivetrain were remarkably undamaged. Field repairability, a hallmark of American design philosophy, was evident even in this captured vehicle. Components could be removed, replaced, and returned to operation in hours rather than days. The Japanese engineers, accustomed to the delicate, maintenance-intensive Type 90-7 engines, noted this with both envy and concern. Further study revealed the Sherman's wet stowage, designer, a modification that protected ammunition with water and glycol jackets, was not something the Japanese had anticipated. Although the development of wet stowage would not become widely known until after the war, the practical effect was evident. The 75mm shells had survived penetration without cooking off. The crew realized that a doctrine based solely on penetration and destruction was now obsolete in practice against this tank. The broader strategic implications became clear as they pieced together field intelligence and captured reports. Japanese anti-tank crews had been taught that frontal assaults against medium tanks were likely to disable or destroy the enemy in a single engagement. Yet the Sherman's combination of angled armor, resilient ammunition storage, and mass repairability rendered this assumption invalid. Every engagement they thought predictable was now fraught with new variables. This moment marked a psychological shift. The Japanese had previously relied on fear, surprise, and the assumption of enemy fragility. A single Sherman's resilience challenged the fundamental belief that they could achieve battlefield parity with their existing arsenal. As Kato noted in his post-war memoirs, seeing the Sherman in the jungle, intact yet disabled, altered our perception. We realized the enemy's strength was not only in firepower, but in preparation, production, and repair. A single vehicle symbolized an entire logistical system that we could not hope to match in the remaining months of the war. The encounter also had immediate tactical consequences. Frontline units, after receiving reports, became hesitant to engage Shermans directly. Commanders who had once relied on aggressive maneuvers now found themselves reconsidering distance, angle of approach, and the role of terrain. A tank that could take a hit and survive not once, but consistently across multiple encounters, undermined training and operational doctrine, simultaneously. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. In parallel, the Japanese engineers attempted rudimentary experiments to replicate the effect. Using captured fuel, ammunition, and spare armor, they constructed mock-ups to test survivability. Yet, no combination could replicate the Sherman's endurance and internal safety measures. The disparity between expectation and reality was more than mechanical, it was systemic. By the time the Japanese army faced the full-scale American armored advance on Okinawa, the lessons from the captured Sherman were largely theoretical. Field crews had been shaken but lacked the resources to adapt. Even if they had understood the mechanisms of wet stowage and robust repairability, production limits, fuel shortages, and logistical collapse rendered meaningful replication impossible. This single encounter encapsulated a broader truth. Of the late Pacific War, the United States' ability to combine superior industrial output, engineering foresight, and tactical application often created advantages that could not be countered by valor or doctrine alone. The psychological impact on Japanese crews expecting a swift, fiery victory against each tank they encountered. The captured Sherman, in its silent resilience, had become more than a vehicle. It was a symbol of a systemic advantage, one that could neither be destroyed nor ignored. Its 75mm gun, intact ammunition, and repairable engine embodied the very lessons that would only become widely understood long after 1945. In modern mechanized warfare, survival and sustainability often outweigh singular destructive power. As the sun set over the scarred Okinawan hills, the Japanese tank crews departed the captured Sherman with a mix of awe, frustration, and a grim awareness that the battlefield was no longer a contest of chance or bravery alone. The Japanese engineers and officers returned to their forward command post with detailed sketches, measurements, and notes on the captured Sherman. Their reports, compiled meticulously over the next days, highlighted both the mechanical marvel they had encountered and the operational lessons it imposed. Yet the larger reality weighed heavier than their technical curiosity. Their entire armored doctrine, honed over decades, rested on assumptions now proven incomplete. Lieutenant Hiroshi Kato reflected privately in his journal. We had believed that a tank's destruction was inevitable once penetrated. The Sherman has shown us that destruction is not only a matter of firepower, but also of design, preparation, and foresight. A single vehicle has demonstrated what our intelligence failed to comprehend for years. The immediate operational consequence was hesitation among frontline units. Reconnaissance reports warned of Shermans operating in well-coordinated formations, backed by infantry and artillery, often supported by repair crews. Japanese gunners, previously trained to approach medium tanks aggressively, now exercised extreme caution. Every frontal assault became a gamble, and the confidence that had fueled early successes against American armor began to erode. Beyond the tactical and psychological, the strategic implications were profound. Japan's tank production, already limited in scale, quality, and reach, could not hope to produce vehicles capable of matching the Sherman's combination of firepower, survivability, and maintainability. The disparity in industrial capacity between the United States and Japan meant that the Sherman was not an isolated advantage, but a glimpse into the systemic imbalance that would shape the final year of the Pacific War. Cato's reports also noted an unexpected revelation. The American approach emphasized repair and reuse. Captured or damaged, Shermans could often be restored to combat-ready status in days rather than weeks. In contrast, Japanese tanks, particularly the Type 97 and Type 95 models, required specialized parts, skilled maintenance crews, and time-consuming repairs. This reinforced a critical vulnerability. Attrition was not symmetrical, and the Japanese could not replace losses at the rate the Americans could. The enduring lesson of the captured Sherman reached beyond immediate combat. Training manuals, tactical assumptions, and even morale were affected. Soldiers who had assumed invincibility in their weapons now confronted the reality that technology, logistics, and preparation could outweigh courage and skill alone. Every engagement, every defensive line, and every planned counterattack required a reassessment of what could be achieved and at what cost. As the months progressed, Kato and other officers disseminated their findings within the regiment. It exemplified the combination of engineering foresight, industrial capacity, and battlefield pragmatism that American forces had leveraged consistently. Japanese units, lacking the resources to replicate or counter it effectively, faced the sobering truth that technological and logistical superiority often determined outcomes before combat even began. By the time of the formal surrender in August 1945, the lessons of the captured Sherman had become part of post-war analysis. American historians would later note how such encounters illuminated the broader pattern of material advantage that defined the Pacific theater. Individual skill mattered, but industrial planning, innovation, and sustainable design shaped the war's final outcome. The Sherman, in its quiet, resolute survival, symbolized the principle that would endure far beyond Okinawa. In modern warfare, resilience and preparation could redefine the battlefield as decisively as firepower itself. The captured Sherman, resting silently in the Okinawan jungle, left an indelible imprint on the minds of those who studied it. For the Japanese crews, it represented not a single tactical failure, but a structural, almost philosophical shift in understanding the nature of modern armored warfare. Their belief in predictable outcomes and assumed enemy fragility had collided with the immutable reality of American industrial ingenuity. In retrospect, the story of the captured Sherman offers more than a technical lesson. It captures the human experience of encountering the unforeseen, the shock, the recalibration of expectations, and the gradual recognition that the rules of engagement had changed. Lieutenant Kato's final reflections, penned after the war, summarized the psychological truth that had quietly taken root in those Okinawan hills. The Sherman was not merely a machine. It was a revelation. It forced us to see that war is not only fought with courage and doctrine, but with foresight, endurance, and the quiet power of preparation. To witness it was to understand the limits of our assumptions and the magnitude of the opponent's advantage. And so, the captured Sherman became both a tangible artifact and an enduring symbol, proof that even in a war defined by fire and blood, some victories and some lessons are won silently, through design, planning, and the quiet, unyielding resilience of steel. The encounter left a final, haunting truth in its wake. In the theater of the Pacific War, survival was no longer random luck or chance. It was engineered, calculated, and systematically reinforced a reality the Japanese forces could neither ignore nor counter in the war's final chapters. The Sherman, 75mm gun intact, ammunition unharmed, and systems operational despite enemy fire, had rewritten the rules of armored warfare in a single, unassuming lesson. It remained a testament to the subtle, often unseen factors that shape history, reminding all who studied it that the true measure of power often lies not in what is destroyed, but in what endures. Following the Okinawa encounter, Japanese military engineers and strategists undertook a series of post-action analyses aimed at understanding the full implications of the Sherman's survivability. They combed through battlefield reports, interviewed returning crews, and catalogued instances where American medium tanks withstood hits that would have destroyed their Type 97 Chi-Ha or Type 95 Ha-Go counterparts. Each new data point confirmed what the captured Sherman had already revealed. the assumptions underpinning Japanese armored doctrine were fundamentally flawed. The core problem lay not solely in armor thickness or gun caliber, but in the holistic American approach to design, whereas Japanese tanks had been conceived primarily for infantry support, favoring mobility and ease of production over survivability. The Sherman embodied a balance: sufficient armor to absorb medium-caliber fire, when a 75mm main gun, capable of countering the majority of Japanese armor at long range, and a mechanical reliability that allowed sustained operations across hundreds of miles. Technical officers documented one key revelation: the Sherman's internal layout dramatically reduced the risk of catastrophic ammunition detonation. In contrast to Japanese designs, which placed stowed shells close together in poorly ventilated compartments, the Sherman used compartmentalized racks with interleaved protective bulkheads. In the Okinawa capture, Japanese engineers could see firsthand that even when penetrated, the water-cooled ammunition storage system prevented immediate ignition. This explained why many Shermans continued fighting after hits that would have destroyed a Chiha instantly. By analyzing the 75mm gun itself, engineers gained another uncomfortable insight. Their manuals had long emphasized that medium-caliber weapons were only effective at close range, particularly against lighter Japanese tanks. Yet, the Sherman's gun was capable of penetrating Chiha frontal armor at over 2,000 yards, a range that exceeded the effective engagement envelope of the Type Noventi CT's 37mm main gun by a wide margin. This meant that American crews could engage, neutralize, and survive encounters before the Japanese could effectively respond. These technical lessons rippled through tactical evaluations. Training protocols that had once emphasized aggressive frontal assaults were reassessed. Junior officers were instructed to consider standoff engagement and combined arms coordination concepts that were logistically and culturally difficult to implement given Japan's limited resources and prevailing doctrine. Even the most sealess tank commanders had to acknowledge a humbling truth: they could not simply rely on courage, crew skill, or surprise to win battles. The mechanical and structural advantages of the Sherman dictated terms long before combat began. The psychological impact was equally profound. Unit morale, previously buoyed by the knowledge that Japanese armor could dominate numerically equivalent engagements, began to waver when reports of indestructible Shermans circulated. Soldiers who had assumed near invulnerability for their vehicles now faced a new, unsettling reality. Every encounter carried unanticipated risk. Lieutenant Kato wrote in a confidential note, "Our pilots and crews must now fight not only the enemy, but the limitations of our own assumptions." Despite these revelations, the Japanese industrial and logistical limitations prevented them from implementing meaningful countermeasures. Unlike the United States, which could experiment, mass-produce, and deploy updated designs rapidly, Japan's factories were overstretched, supply chains disrupted by American submarine warfare, and critical raw materials increasingly scarce. The Sherman's edge, therefore, was not simply tactical but systemic, a structural advantage Japan could neither erase nor replicate in the remaining years of the war. The long-term consequence of these observations became clear in subsequent engagements, where Japanese tank units had once counted on ambushes and numerical superiority. They increasingly found themselves outgunned and outmaneuvered. Even when employing traditional tactics, concealment, night attacks, and terrain exploitation, the resilience and firepower of the Sherman limited their effectiveness. Operational losses accumulated at unsustainable rates, reinforcing a broader lesson. Technological and industrial capacity could decisively shape outcomes independently of individual heroism or battlefield valor. By war's end, the captured Sherman had transcended its immediate tactical significance. It was a case study in engineering foresight, survivability, and the interplay between industrial strength and battlefield effectiveness. Its capture in Okinawa provided the Japanese with undeniable proof that victory was not solely determined by strategy or courage, but by the structural realities of design, production, and maintenance. Even decades later, post-war analysis of Pacific armored engagements repeatedly referenced the captured Sherman as a turning point in Japanese perception. It symbolized the mismatch between assumed enemy vulnerability and actual capability. For historians, it remains a striking example of how a single piece of machinery studied carefully and understood in depth can illuminate the broader dynamics of industrialized warfare, influence tactical thought, and reveal the often overlooked factors that determine who survives, who prevails, and how history remembers their struggle. The Sherman's lesson was clear and enduring. True advantage in modern warfare rarely lies solely in courage or doctrine. It lies in preparation, adaptability, and the ability to anticipate and engineer resilience into the very tools of combat. For those Japanese crews who witnessed it, and for the scholars who later studied it, that insight would resonate far beyond the jungles of Okinawa, shaping both memory and understanding of the Pacific War in ways the soldiers who fought it could scarcely have imagined. The captured Sherman, 75mm gun intact, armor holding, and ammunition safe, had quietly done what no human effort alone could. It redefined the battlefield, reshaped perceptions, and left an indelible mark on the history of armored warfare. In the months following Okinawa, intelligence officers, engineers, and tactical analysts in Japan continued to reference the captured Sherman in reports that circulated cautiously among Though the war's trajectory had already begun to turn against them, the insights gained from examining the tank offered a sobering confirmation. Japanese armored doctrine, industrial strategy, and battlefield assumptions were misaligned with reality. Every report emphasized the same points: its 75mm gun outranged and outclassed domestic tanks. Its armor was survivable even under repeated medium-caliber hits, and its internal systems dramatically reduced the likelihood of catastrophic loss. The immediate aftermath for frontline units was equally instructive. Tank crews, once confident in their ability to dominate small-scale engagements, were forced to reconsider tactics. Ambushes against Shermans no longer guaranteed success. Japanese crews had to engage at greater distances, adopt more complex combined arms strategies, and rely on artillery or air support to supplement their efforts. Many officers noted in private diaries that these adjustments often arrived too late to prevent heavy casualties. In effect, the Sherman had imposed a new operational calculus on the battlefield. The balance of risk had shifted decisively against Japanese armor. Meanwhile, engineers who had studied the captured vehicle attempted incremental adaptations to domestic tanks. Proposals included thickening frontal armor, revising ammunition stowage, and experimenting with higher velocity guns. However, these efforts encountered severe constraints. Raw material shortages, frequent Allied air raids on factories, and logistical bottlenecks meant that no substantial redesign could be fielded in meaningful numbers. In practical terms, the Sherman's edge was permanent. Its advantages could not be matched by Japanese industry in the short or even medium term. From a broader strategic perspective, the captured Sherman exemplified a recurring theme in the Pacific War. Industrial capacity and design, foresight, frequently outweighed sheer numerical superiority. While Japanese forces could often assemble large formations and execute daring maneuvers, they could not compensate for the systemic benefits inherent in American armored vehicles. The psychological impact on commanders was significant. Reports circulated noting that confidence in conventional Japanese tank tactics had eroded. Some officers openly questioned the wisdom of engaging American armor in direct confrontation, recognizing that the tactical assumptions underpinning years of doctrine were no longer valid. The legacy of the Sherman in Japan extended beyond the war itself. Post-war analysis and memoirs repeatedly referenced the Okinawa capture as a vivid example of the interplay between engineering, production capacity, and battlefield effectiveness. It served as a teaching tool for future armored warfare studies, illustrating that battlefield outcomes are shaped as much by design and preparation as by individual heroism. The tank became emblematic of a wider truth. In industrialized warfare, human courage alone cannot overcome the structural advantages embedded in machinery, logistics, and technological innovation. For the soldiers who first laid eyes on it, the Sherman was both a curiosity and a harbinger of an uncomfortable reality. Lieutenant Cato, writing years later in his memoir, reflected on that first encounter. "We approached it with the hope of understanding, yet what we discovered was a mirror held up to our assumptions. One machine, carefully designed and produced, revealed the limits of our courage, the vulnerability of our doctrine, and the inevitability of industrial power." Ultimately, 1904, the captured Sherman story, is a testament to the quiet yet decisive influence of material reality in warfare. Its 75mm gun, resilient armor, and innovative internal design did more than survive. Okinawa, they reshaped understanding, challenged long-held beliefs, and highlighted the profound consequences of industrial and crass technological imbalance. While individual acts of valor defined moments of combat, it was the combination of foresight, engineering, and production that left a lasting imprint on history. In the end, the Sherman stood not merely as a vehicle, but as a symbol, a reminder that the outcomes of war are rarely determined solely by human determination. Often, they are dictated by the thoughtful integration of design, preparation, and industrial capability, a lesson the Japanese learned too late, but one whose implications would resonate in armored warfare for decades to come. The tank, unremarkable to the casual observer yet extraordinary in its capacity to alter perceptions, had done what no single soldier could achieve. It reframed an entire theatre of war, demonstrating that in the crucible of modern combat, the tools of battle can be as decisive as the men who wield them. And so, the captured Sherman, 75mm gun intact, armor holding firm, and internal systems functioning as designed, left behind a quiet but enduring legacy, a benchmark of resilience, a testament to industrial foresight, and a revelation of the harsh truths that define war. Its story, preserved in reports, memoirs, and technical studies, continues to illuminate the subtle but unyielding forces that shape history. Even as the war drew toward its final months, the implications of the captured Sherman continued to ripple through Japanese military thinking. Field commanders now faced a dilemma that earlier doctrine had never anticipated. The old assumptions about the vulnerability of American armor no longer held. After every engagement where a Chiha or Type 97 was pitted against a Sherman, reports filtered back to Tokyo noting repeated failures and disproportionate losses. Tactical manuals were quietly revised, yet the structural realities, industrial limitations, shortages of high-quality steel, and insufficient artillery support meant these theoretical corrections could not translate into meaningful battlefield advantage. Engineers, tasked with improving domestic tanks, found themselves constrained not only by resources, but also by the pressing demands of defending scattered islands across the Pacific. Attempts to replicate the Sherman's armor thickness or the 75mm gun proved largely academic. Even if prototypes could be produced, there was no capacity for mass deployment. Meanwhile, captured parts and photographs of the Sherman circulated in technical circles, serving as both inspiration and frustration proof that Japanese industry could not keep pace in either quantity or quality. The psychological impact on troops cannot be understated. Veteran tank crews, who once prided themselves on maneuver warfare and the ability to outflank or destroy any enemy vehicle, now faced a sobering reality. Their tanks were no longer the masters of the battlefield. A single well-placed Sherman round could destroy what previously would have required multiple hits. Letters and diary entries from officers on Saipan, Leyte, and Okinawa reveal a recurring theme: awareness of technological inferiority compounded the stress of combat, sapping morale even in moments of tactical success. At the highest levels of command, the Sherman served as an unspoken metric of strategic imbalance. Reports highlighted that American tanks, like infantry and air support, were products of a system that combined industrial capacity, engineering ingenuity, and battlefield experience. Japanese planners recognized that no amount of training or bravery could fully offset these advantages. In effect, the captured Sherman had become a symbol, a tangible representation of why Japan's armored doctrine had been rendered obsolete in the Pacific theater. In post-war reflection, historians would note that the Sherman's capture was more than a single intelligence coup. It crystallized the reality that modern warfare was increasingly defined by material, production, engineering precision, and system-wide efficiency. As Lieutenant Kato observed in his memoirs years later, confronting the Sherman forced Japanese officers to face the uncomfortable truth that courage without preparation and skill without tools is fragile against the calculus of industrialized conflict. The enduring lesson of the captured Sherman extends beyond World War II. Military academies around the world continue to use its example to illustrate how battlefield outcomes are influenced not merely by heroism, but by the integration of technology, production, and doctrine. It remains a case study in the interplay between perception and reality, demonstrating that the moment when beliefs collide with empirical evidence can be both humbling and transformative. In the end, the 75mm gun that had punctured the armor of Chiha tanks at 2,000 yards, the resilient hull that withstood multiple engagements, and the internal innovations that preserved crew survival, collectively stand as a testament to foresight, design, and industrial capability. The Sherman was more than a weapon, it was a lesson written in steel, a narrative of the subtle forces that define victory and defeat, and an enduring reminder that in warfare, reality often outweighs doctrine, and preparation often outweighs valor. Even decades later, as analysts reviewed photographs, diagrams, and battle reports, the captured Sherman continued to provoke reflection. It was a silent witness to the limits of human ingenuity when uncoupled from material means, a persistent reminder that in the crucible of war, the consequences of industrial foresight are measured not only in destroyed vehicles, but in lives preserved and assumptions overturned. Ultimately, the Sherman story illustrates a profound historical irony that a single, well-designed, and thoughtfully produced machine could so fundamentally alter perceptions, force a recalibration of doctrine, and expose systemic vulnerabilities long before the war's final battles were fought. Its legacy is quiet, yet enduring, a testament to the subtle but decisive influence of engineering and industrial power on the human experience of conflict. This concludes the narrative of the Japanese examination of the captured M4 Sherman. Its tactical, technological, and psychological ramifications, and the enduring lessons it imparted for both contemporary and future generations of military thinkers. By the time the war in the Pacific reached its final phases, the ramifications of the captured Sherman had fully permeated Japanese strategic thought, even if they could not be acted upon effectively. Technical reports circulated quietly among engineering bureaus, highlighting weaknesses in Japanese armored doctrine that were impossible to rectify under wartime constraints. Photographs, sketches, and crew testimonies from captured vehicles were catalogued, analyzed, and cross-referenced, creating a body of knowledge that offered insight, but little immediate solution. On the islands of the Central Pacific, where remaining Chiha tanks continued to face superior American armor, officers often referenced the Sherman's capabilities when planning defensive positions. Reports noted that terrain, ambush tactics, and improvised fortifications were no longer enough to offset the combination of firepower, armor, and crew survivability demonstrated by American tanks. In some cases, local commanders experimented with increasing armor thickness on the front of existing tanks, reinforcing critical components with salvaged steel, or adjusting engagement ranges. However, these adaptations were piecemeal, inconsistent, and rarely capable of matching the Sherman's design advantages. The psychological imprint on Japanese soldiers was profound. Tank crews who survived encounters with Shermans described a new, chilling awareness that their weapons, once symbols of dominance, were now vulnerable to an enemy who could strike from beyond effective range and survive counterfire. Diaries and post-war memoirs emphasize the quiet dread that accompanied these engagements, a stark contrast to the confidence previously instilled by doctrinal training and battlefield experience. Lieutenant Colonel Sato, who commanded a mechanized unit on Saipan, later wrote that witnessing a Sherman obliterate a line of Chi-Ha tanks felt like watching the future arrive, unstoppably and unyielding. In Tokyo, engineers and planners faced a difficult truth. Japan's industrial limitations had constrained the evolution of domestic armor. The Sherman demonstrated not only the advantages of superior design, but also the importance of mass production, crew protection, and logistical integration areas in which Japanese industry lagged due to resource scarcity and strategic overextension. The captured vehicle became a quiet benchmark for what could have been, a standard that Japanese designers could study but not fully replicate under the pressures of wartime scarcity. Even after the surrender, the story of the captured Sherman continued to inform military thought. Allied forces, aware that captured equipment had provided critical intelligence to the Japanese, recognized the dual-edged nature of battlefield technology, how a single vehicle could shape doctrine, morale, and strategic planning far beyond its immediate tactical impact. For historians, the narrative underscores a recurring lesson in warfare, that technological advantage and material capability can redefine the battlefield long before human actors fully comprehend it. In retrospect, the captured Sherman story represents a convergence of material ingenuity, tactical reality, and psychological insight. It illustrates how a single piece of equipment can catalyze profound shifts in understanding, forcing even a highly disciplined military to confront its own limitations. The legacy of the Quattro Sherman is thus twofold. To exemplify the power of thoughtful design and industrial foresight, while also serving as a cautionary tale about the fragile assumptions on which military confidence often rests. Ultimately, the Japanese examination of the Sherman offers a lesson that extends far beyond the Pacific theater. It is a testament to the interplay between perception and reality, doctrine and evidence, courage and preparation. In the quiet steel of the captured tank, history preserved a story of innovation, adaptation, and the unrelenting truths of industrialized conflict, one that continues to resonate in military studies and historical reflection to this day. This closes the final portion of the narrative, capturing both the immediate and lasting consequences of the Japanese encounter with the captured M4 Sherman and the enduring lessons it left for the conduct of war, the psychology of combatants, and the evolution of armored warfare strategy. Even after the formal surrender, isolated pockets of Japanese forces in remote islands continued to grapple with the practical and psychological implications of encountering the Sherman. Veteran tank crews who had survived direct engagements recounted their experiences with a mixture of awe and resignation. In letters home, scribbled in cramped kanji, some described how the Quattro's 75mm gun punched holes like lightning through Chi-Ha armor, leaving a visceral impression that no doctrinal manual could erase. The Sherman had become, in essence, a ghost in their collective memory, an unstoppable adversary whose lessons were forever etched in the minds of men who had once believed in the invincibility of their own machinery. At the Army's technical bureaus in Tokyo and Kyoto, engineers continued to study the recovered vehicle for months. Reports meticulously detailed the armor layout, the suspension system, the engine compartment, and the ammunition stowage. Type 97 Chi-Ha to the newer Type 3 Chi-Nu, noting both deficiencies and possible mitigations. Yet, even the most innovative minds were limited by available resources. The Sherman's combination of firepower, armor integrity, and production efficiency remained aspirational, a standard that Japanese industry could never fully meet in wartime conditions. Field reports emphasized that the psychological impact on crews often outweighed the technical analysis. Units facing the Quattro Sherman tended to fight more cautiously, overcompensating with ambushes or night engagements, attempting to exploit terrain rather than confront the tank in open battle. This was a stark contrast to pre-war doctrines that emphasized aggressive maneuver and bold armored thrusts. Veteran tankers later recounted how even a single Sherman could immobilize or deter multiple Chi-Ha tanks in the same engagement simply by appearing in a favorable firing position. The notion that one tank could dominate an entire battlefield became a lesson written not in textbooks but in lived experience and battlefield trauma. By early 1945, Japanese armored units were almost entirely defensive in nature. Engineers and commanders recognized that without a radical redesign or a massive influx of material, any attempt to replicate the Sherman's effectiveness was futile. In training simulations, the Quattro Sherman became a standard adversary, a symbol of an enemy's industrial and tactical superiority, used to prepare crews for a conflict they increasingly could not win. Students were drilled not to underestimate firepower and to seek creative approaches to compensate for technical inferiority, often relying on terrain concealment and calculated retreat. The Sherman's legacy, therefore, was not limited to the battlefield. Post-war memoirs, interviews, and technical papers all underscore a recurring theme: that the psychological revelation of encountering an opponent with superior technology could reshape strategy as profoundly as any battle outcome. The Quattro Sherman had, in a very real sense, transcended its role as mere hardware, becoming an instrument of learning, reflection, and eventual historical interpretation. Even today, historians studying Japanese armored operations cite the captured Sherman as a pivotal case study. It exemplifies how a single piece of equipment, when subjected to careful analysis, can expose structural weaknesses, illuminate doctrinal flaws, and challenge ingrained beliefs about technological and tactical supremacy. In the broader narrative of World War II, this encounter stands as a reminder that material reality often arrives before perception can catch up, and that understanding this gap can be as decisive as any battle maneuver. Thus, the story of the Japanese examination of the Sherman concludes not with an explosion or dramatic victory, but with quiet revelation. Through steel, firepower, and engineering, it imparted lessons that no battlefield defeat or propaganda could erase, a testament to the enduring power of evidence, analysis, and the sobering truths of warfare. The final months of the war saw the cumulative effect of these lessons manifest in operational planning. Japanese commanders, acutely aware of the Sherman's capabilities, increasingly avoided direct tank engagements, especially in open terrain. Where once they would have relied on bold maneuvers and frontal assaults, now they emphasized ambushes, fortified positions, and improvised anti-tank measures. The Type 97 and Type 3 series, while competent in earlier conflicts, were recognized as vulnerable against the 75mm firepower of the Sherman, even when positioned advantageously. Commanders instructed crews to exploit every natural obstacle, rivers, forests, and ridges as force multipliers against a weapon they could not hope to match directly. In Okinawa, and later in the defense of the home islands, reports circulated among tank units describing previous encounters with the Quattro. Tales of small Sherman detachments repelling superior numbers of Chi-Ha and Type 3 tanks became the subject of both fear and grudging admiration. Officers stressed that technical inferiority demanded ingenuity and caution. In some cases, units resorted to kamikaze anti-tank tactics, employing explosive charges and desperate maneuvers against advancing Shermans, reflecting the psychological toll exacted by facing an enemy perceived as technologically invincible. Meanwhile, intelligence and engineering bureaus continued detailed studies. Photographs, captured components, and even surviving manuals from downed Shermans were meticulously analyzed. Reports evaluated armor thickness, turret rotation, suspension resilience, and gun accuracy. One repeated observation stood out: the combination of mobility, firepower, and production consistency was unprecedented. Japanese engineers noted that even with identical resources, duplicating the Sherman's efficiency would require a level of industrial coordination and logistical depth that Japan could not achieve under wartime conditions. The human element, however, remained the most striking aspect. In interviews conducted decades later, Surviving Japanese tank crews consistently highlighted the psychological impact of facing a Sherman. Unlike prior encounters with armored vehicles, the Quattro forced them to confront a reality in which traditional tactics and bravery were insufficient. Soldiers recounted the chilling moment when a Sherman fired from beyond their expected engagement range, perforating armor that they had long considered adequate. This gap between expectation and reality induced a profound caution, reshaping both training and morale. Even post-war, the Sherman remained a benchmark for evaluation. Recovered vehicles were studied in two laboratories and military academies, influencing the design of future armored vehicles across the globe. Japanese engineers and historians alike recognized that the M4 Sherman was not merely a battlefield instrument, but a catalyst for doctrinal evolution, a measure of what industrialized warfare could achieve when engineering, production, and strategy converged. In reflecting on this episode, the story of the Japanese examination of the Sherman illustrates a broader truth of World War II, that knowledge gained through meticulous observation and analysis could be as consequential as victories achieved in combat. The 75mm gun, the sloped armor, the robust suspension, each element, when studied and understood, provided insight into the interplay of technology, human decision-making, and industrial capacity. For the men who faced it, and for those who later dissected its design, the Sherman was both adversary and teacher, reshaping perceptions and leaving a legacy that extended far beyond the immediate battlefield. By the time hostilities ended, the Sherman had earned a reputation not only as a reliable and effective tank, but as an enduring symbol of the gap between expectation and material reality. It demonstrated that, in war, the confrontation between belief and evidence is often the moment that defines strategy, psychology, and ultimately, history itself. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.